Hello, all right, we're back. This is problem section 717, and the problem reads, this is off of actex, that the average loss size per policy on a portfolio of policies is 100. And it says that actuary 1 assumes that the distribution of the loss size has an exponential distribution with the mean of 100. And actuary 2 assumes that the distribution of the loss size has this PDF where x is greater than 0. And it wants us to find that if M1 and M2 represents the median loss size of the two distributions, find this. And so our goal is to find the median of 1 over median of 2. Okay? So the first one, the median of an exponential distribution is 1 minus e m1 over 100. It's told to us that beta was going to be 100, and we just backwards solve for this, and this will be negative 0.5 e m1 over 100. Take the negative out of it, and we get the log of 1/2 is equal to m1 1 over 100. Take the negative over, we get this log of 2 m1 over 100, of course. Then m1, I'm just going to switch sides, is equal to the natural log of 2 times 100. And that will give us a number of 6931. So that was fast, so we know, hey, what's going on? If they get to this one fast, you know the second one's going to be hard, right? So here we go. Yeah. So we know what M1 is, right? So let's just go ahead and just state what M1 is. 6, 9, 3, 1. But we need to know what is M2. We don't really know what theta is. We know that theta has to be greater than x. That's the only thing that we do know. But x is greater than 0. It's the only thing we do know. How I usually solve it, and this is the wrong way because whenever I was trying to do it, I've always tried to integrate over all possibilities, sum it up to knowing that the probability would be 1, and then backward solve. But that doesn't help me find theta. I mean, it doesn't help me at all. It just gives me you'll see that you come to a calculation error. So the way to attack this problem, at least the way they did it, which is the reason why I'm doing this, is that we're going to first find the CDF of x, which is 0 to x, and then it's going to be 2 that over, we'll call it t here, okay, dt. Let's find the CDF. And then I always like to write my CDF where I have this up here at the numerator, because when I integrate, I have a less chance of making a mistake. So we'll just pray that, and I'm gonna move this on the outside here, and I'm just gonna put 2 theta squared here and move that to the outside, because this is nothing but a constant, okay? It's nothing but a constant. So what we have here is that we have a dilemma inside here. We're going to go ahead and do a u substitution that t is equal to theta. Then the du will be 1, and we're going to change those bounds, right? When with 0, throw a 0 in for t, we'll get theta, and when x goes in, it'll be x plus theta. Du. Look like we're ready now to actually do the integration. Let's go ahead and do so. We go up. So it was negative 3, so now we go to 2, negative 2. And then our integration bounds here is x plus that amount over that amount. So then, one over two over x plus theta, and this is 2 minus 1 over 2 theta. Okay, that's correct. So then we're going to distribute, and we know what we got here. This 2 goes away. We get this 1 over, this would be theta squared x plus theta 2 minus 1. Oh, and this will, and this would be negative, and this would be positive because of that, sorry. So, as you can see, I made a mistake, but I caught it because I was like, hold up, that doesn't make any sense. My f of x has to be 1 plus some minus number. So, to make it clearly write it here, my f of x, or CDF, is 1 minus this number here. So, careful integration, we get that. All right, so now you're wondering, why you do all that? You still haven't found theta. Yeah, I really haven't. But I can, because once I do the expectation, I'm going to find out what the expectation is. Okay? So this expectation, this function should, we'll see what it is, right? So the expectation of x of 2 is, we're going to do the Darth Vader rule. It would be from 0 to infinity of 1 minus f of x of 2, right? dx. Well, that is 0 to infinity, 1 minus all of this. Well, that's leaves us to right here. dx. All right, we can find the expectation just by doing this. So, same thing here. We'll let u equals x plus theta du is 1. So, when we do the integration, let's go ahead and pull out that constant out here. This is my u now. 2, I like to do it this way. du. Nothing else is in there because that thing is out. Okay, then we're going to integrate that, which will be go up 1, right? And we'll go, minus 1, so this is a negative 1. Now, what are our bounds? 0 goes in there, it'll be 0 with theta. Infinity as well as just infinity, right? It doesn't matter, it's going to go to infinity. So then we're left with well, 1, and this is a negative over some infinity number, and this now is going to be positive 1 over theta, because theta goes in there, right? We get theta and infinity. Then this comes out to be, well, of course, this is 0. This comes out to be just theta. And we know what theta was. We're going to claim that theta is going to be that approximately 100. All right. We're going to approximately say that's 100. Okay, he said, Chris, you did all that, but you still haven't found the median. No, I haven't. I have not found the median. But because now I have the CDF and I know what theta actually represents, now I can throw that back in there and solve for my median. So how do you do that, Chris? He said, okay, well, Remember, using my CDF of x of 2, my median is equal to 0.5 here. Now I'm going to look at 50%, and I know what this is. It's 100 squared, and this is what I'm looking for. What point is that plus all of that, whoops, which is not that, it's 100 now, will give me that, right? And if you solve very carefully, you'll find an answer. I don't know, we'll see if I can do it on the fly, but we'll see. Just be negative. So it'll just be still 0.5 is equal to 1 squared over the median 2 plus 100 squared. Then I'm just going to times that here, divide that there. So let's go ahead and say median of 2 plus 100 squared is equal to 100 squared divided by 0.5. And then I can square all of that. Square all of that, right? That will give me m2 plus 100, and that m2 should equal then the square root of 100 squared divided by 0.5 minus 100. And let's see if I can do this in my handy dandy calculator and that I actually did it correctly. I got a 41.42. There's my median. Now I do this here and say 41.42, and then I will actually find what M1 over M2 is, and that will be the answer. .67. Let's go ahead and round it to 1.7 D. So I don't see 1.67. All right. So the actuaries want you to do the CDF and use the CDF to find the expectation, because we needed it to find the point that we wanted to use represent here for the median 2. So doing the expectation and solving what the expectation would be, gave it to us, and we solved the answer.